Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. Today I'm kind of excited to talk about how inheritance allows you to design a very extensible terrain. I'm going to start from this program. This is listing 1010 from my Objects and Games with Python book. So let's look quickly at the important parts of this program, and then we'll use inheritance to enhance it. If we run the program, you can see a window with some terrain. It's an ice castle, let's say, and a character that's a penguin. Never claimed to be an artist. And I can move the character with the arrow keys. There are two kinds of terrain here right now. The penguin can move freely over the blue background tiles, but cannot pass through the white blocks. There is a scrolling background, but that is not the focus of this video. If we look at the code, there are three sprite subclasses here: brick, scrolling background, and penguin, and a main function. If you want to look at this code, as always, it will be uploaded to my GitHub repository with a link in the description. We're going to focus on how the background is created and not on how the movement works. I have other videos on that, and I'll link one here. So the interesting thing is really how the scrolling background object is created, how the brick objects are created, and how they're used in the program. This text file, you can see, is a file of rows of ones and zeros, and this is read in here in the scrolling background's init method and used to create the background. Those ones and zeros are codes that map to different tiles. The zeros are the blocks the penguin can't move through. So already there is some behavior built into the program based on what sort of tile is created at runtime. No matter what this map looks like, when the program starts up, a terrain will be created from this text file in which the penguin can move over ones, but cannot move past zeros. So in the init method, a list of tile images is created, and the method then iterates over the map and builds up the background image by blitting the tiles to the correct coordinates according to where it fits in the image. This is just a nested loop. But in that loop, we also check if the tile is in a list of bricks that are passed in. This is just a list of integers, a list of the codes that correspond to bricks. So I could add a different looking brick, a brick with a different image, that is also a brick the penguin can't walk through. Right now, it's just the zero bricks, because we only have 0 and 1. If it's a brick the penguin can't walk through, we create a brick sprite for it, and we put that in a sprite group. This is a brick that has the same size as our brick image. All bricks are the same size, but it's completely transparent. So it's not visible. It just has a location and size. This will allow us to check for collisions with the penguin down in the main function. So the scrolling background also maintains this group of brick sprites, and ideally with a large background, it would maintain a list of only the sprites on the screen to keep that collision detection very efficient. This is a simple example, so it's just a list of all of the brick sprites. But here's a rule of thumb. Anytime you find yourself writing an if statement, which is something like, if this variable is a something, then do something special, then there's probably a much better object-oriented solution to whatever you're doing. An object should be handling that code, an object that knows whether it's a something or not, and is programmed to do something special if it is a something. And quite often, but not always, those designs involve inheritance. So let's use inheritance to allow us to, in the future, add different terrain with different features, even features we haven't thought of yet. That's what inheritance allows us to do. It allows us to extend a system in the future. Think about inheritance in pygame. Inheritance allows us to subclass sprite and use all of the update, drawing, and collision detection behavior for our own sprites that the creators of pygame never imagined. They imagined a framework, and we can only extend within the framework, but there's a lot of potential there. It's a great framework. In the same way, we'll build a system that allows future us to add terrain with interesting properties. So to start, I'm going to restructure this a little bit for extensibility. What I'm going to do is create a dictionary structure that maps the terrain number from the map to some data related to the terrain object we'll ultimately create. So I'm going to map the terrain number to the class we should instantiate. So should it be none, like our ones, or should it be brick, like our zeros, or should it be some other subclass of, let's say, brick, that we're going to invent in the future? And it will include the image file. And I also want to include a list of groups that the tile object should be added to. This allows me to add the wall tiles to my bricks group to prevent the penguin from walking through them. But it also allows me to come up with any number of other groups in the future with behaviors I can implement and check for without knowing now what they might be. Let's see what that looks like. So I'm going to rename listing 1010 to extensible-terrain.py. And I'm going to create that dictionary first down in the main function. I'm going to annotate a variable terrain data of type dict. I need the bricks group to be created, so before the assets area, I'm going to write a comment, create the terrain dictionary, and then bricks equals pygame.sprite.group. And then I'll create the dictionary, terrain data equals open curly brace, and then I'm going to put 0 colon the empty list and 1 colon the empty list, close. Now let's talk about 1 first, because it's simpler. In the text map, 1 is the terrain that the penguin can walk over. It has no object associated with it, it's just part of the image. And so obviously it wouldn't go into any groups, and the file for that image is icewall.jpg. So in the list, I'm going to put none, that's the class we'll instantiate, no class for the terrain that the penguin can walk over, no special properties. And then I'll load icewall.jpg into a surface, and then an empty list, because obviously the non-object is not going to be put in a group. Now for 0, that's the interesting one. I'll write brick, because that's the class we're going to instantiate, and then I'll load iceblock.jpg, and then I want to put that into the bricks group, so the list consisting of bricks. So then I'll change the next comment to set up the rest of the assets. And I've already removed the code that previously created the bricks group. Now we're going to change the creation of the scrolling background to pass in the dictionary instead of the image files, which I'm going to delete, and the list consisting of 0. What we're doing now is much more general. This code was designed to handle one special case. Now we're writing more general code that will handle a variety of special cases by allowing us to specify classes and groups that will be defined in the future. So now we just have to change the initializer of scrolling background to take this new parameter and work with it and make sure this still works. Up in the initializer of scrolling background, change the parameters to be terrain data, a dict, and then terrain file, a string. Now, down where we're creating the terrain for row in terrain map, that's the text file, we're going to use I, the value we've read from the file, so right now that's a 0 or a 1, to index into our dictionary. I from the map is the key into the dictionary. So instead of if int I in bricks, which is just a special case for this specific terrain, we'll write if terrain data sub int I sub 0. That might be a little confusing. Look at our terrain data dictionary. Terrain data sub 0 or terrain data sub 1 is a list. So the value from the text file is our key that gives us the list with the information about that kind of terrain. And then sub 0 is the first element of the list, the class of the object we should create. If it's none, if terrain data sub int I sub 0 is none, then Python treats that like false. But if it's not none, Python treats that like true, and there's some sort of object we should create. So then we'll need a variable, let's call it tile. That can be of type brick, which is our superclass for all bricks that will be created. I'll annotate that. And right now, we're just going to pass the parameters that we're passing to brick. So tile equals, And now we're going to use our dictionary again. We know that terrain data subint I sub 0 is the class, so we'll write that. So imagine that's brick, or some subclass of brick. And then open paren, the same parameters as before, x, y, tile size, tile size. We'll put a comment over it. The first element in the list is the class of the object to create. And then we'll need to add it to every group in the list of groups. So for group in terrain data subint I sub 2, that's the list of groups, group.add tile. And we'll put a comment over it. The third element in the list is the list of groups to add the brick to. Let's get rid of self.bricks and all code that works with that list. The scrolling background is not going to manage that in this version of the program. Notice that background is managing the location of the bricks in this scroll method. So we'll have to pass in a list of groups here so the bricks can be moved and change the code accordingly. I'll call the parameter brick groups. I'll write for group in brick groups, for brick in group. I'm going to quickly look for invocations of scroll and add that parameter. There's only one. So if the background has to scroll, we'll pass it all of the groups of bricks in a list so it can move all of the bricks too. Okay, and there's one other thing we need to change in init, and that's the images. I previously had passed in a list of image file names, but now we'll get the images out of the dictionary. So I'll delete the code related to tile files, the old parameter, and then within our loop, instead of blitting tiles sub int I, we'll blit terrain data sub int I sub 1, the index of the image in the list in the dictionary. This code also uses the size of the tiles to calculate the size of the entire surface. So we can access the 0th image to do that. I'm going to make the assumption the image exists so that it's not more complicated than it needs to be for now. And I just realized I'm not going to be able to load these images until I've created the screen. Okay, and I see some code down here that needs to be removed. And let's make sure our program still works. I'll just move the penguin around. Can't move through walls. The background still scrolls. And the bricks are still impenetrable. Seems to work. Awesome. Now we can subclass brick and see how this can be enhanced through inheritance. Okay, so my first subclass idea is a little silly, and it's just to demonstrate how this will work. I'm going to subclass brick and call it disco brick. So class disco brick, and then in parentheses brick. And now brick is a subclass of sprite, so disco brick is a brick and is a sprite. We get both sets of behaviors. And then I'll write its init method. It will take the same parameters and pass them up to the super. In fact, I'm just going to copy brick here and make those changes. So up in brick, when we call super, the brick is created, the invisible surface becomes the brick's image, etc. And when the move message is sent, brick's move will be called unless we override it. But we don't need to do that for disco brick, so I'm going to delete everything else except super init right now. We might not even need that, but let's leave it for the moment until I've figured out what I need. What I do want is an update method. I want disco brick to look like something, yes. So I want it to have a field. I'm going to give it a field called counter and int. And we'll initialize that to a random number between 0 and 100. And I'll import random. and we'll write an update method. We can do that because this is a sprite, and we'll then be able to send the group it's in the update message, and this update method will be invoked, and if we send draw, it will draw. For disco bricks update method, I'm going to increment the counter, and then if it's reached 120, I'm going to fill the bricks image with a random color. So self.image.fill and then random.randint 0, 255 for each of R, G, and B. And when the counter's 180, I'll set the color back to black and the color key back to 000 so it's transparent again, and set the counter to 0. I'm actually going to pause the video and add a little bit more code here to make it look more like a light is shining through the block, partly using a PNG I'm going to blit over it and partly using Pygame's new color class. But I don't want to get distracted, I just want to make it look slightly better. Okay, so what is the point of that? Well, this brick will just randomly change color at intervals. It's just fun, like a disco floor. Now we have to hook it into our program. So first, I'm going to put some 2s in our terrain file. Those will correspond to disco bricks. I'm going to replace the 1s, which match the behavior of the disco bricks most closely. The penguin will be able to walk over them. I'll make a little dance floor of 2s. And now we need to add information to our dictionary. So I'll add a key 2. And then in the list, we'll put the name of the class, disco brick. And then I'll use the same underlying image as for the regular terrain, icewall.jpg. But now I'm going to have a group for the disco bricks. So I'll create a group called disco and annotate it, and I'll have a list consisting of disco in the dictionary. Now, so after the scrolling background init executes, there will be a group called disco containing our disco bricks. So we just want to allow them to update and draw. So down at the bottom of the game loop, I'll write disco.update and disco.drawScreen. I'll have the disco bricks draw after the background and before the penguin. And when we have the background scroll, we want to add the disco bricks to the list of bricks that should be moved when the background scrolls. Let's run that. We get floor tiles turning on in random colors, and as the penguin moves, the tiles appear to stay in place. So they're also being moved with the rest of the scrolling background, and the penguin can walk over them. Now, honestly, after this video is over, I'm sure you could figure out how to make the penguin dance whenever he walks over those bricks, which would be fun, or play a little Bee Gees. But we're going to move on to more terrain. Now let's do one with something more like what you'd think of as behavior, and show how we can do that with the same structure that we've created through inheritance. I'm going to edit the terrain file again. I'm going to replace the 2s, no disco bricks in this version, with 1s, and then put in some 3s and 4s. Now I'm going to copy disco brick and paste it in and call it portal. And I'm going to draw a different animation over the tile, so I'm just going to take a moment and program that in. It's not important, but maybe we want to consider sprite sheets rather than a single surface for our dictionary and for our superclass brick so that we can handle animated tiles. Anyway, for now I'll draw something, and I'll just pause the video and come back when it's done. So in our dictionary, we'll have to make entries for the keys 3 and 4. I'm going to copy the entry for 2 and paste it in twice and make the key for one copy 3 and the other copy 4. I'll keep the same image, but the class for these will be portal. And I'll create two new groups, portal in and portal out, one for 3s and one for 4s. Okay, now I'm going to give both portal groups an update and draw down at the bottom where the disco group is. Remember, we're not going to have disco bricks this time, but I'll just leave that code in. And I'm going to add the groups to the background scroll call. And first of all, let me run it. How easy is that? Adding some fun behavior will be a tiny bit more work, but see how easy it is to add some new terrain to our program. Now, let's give the portal bricks some behavior. They're already in groups. So after we check that the penguin hasn't walked into a wall, let's check for a collision with our new portal in group with the code if pygame.sprite.sprite collide penguin portal in false. And for conditional code, let's randomly choose a new portal from the portal out group for the penguin to emerge from. Obviously, this would be much more fun with an animation and some sound, but you can add or do anything you like. I'd add that in the penguin class upon collision with the portal. This is just a demonstration of how we can easily add behavior with inheritance. I'm going to pass the sprites from the portal out group to random.choice. So random.choice portal out sprites. And I'll store the result in a variable called newBrick, which will be a portal brick. So in other words, when the penguin steps over a portal, I'm going to select a random other portal to move the penguin to. And then we need to teleport, essentially, the penguin to that new brick. So penguin.rect equals newbrick.rect.copy. The rect is how sprites locate themselves. Now, bear in mind our penguin is sometimes going to be off screen, but let's run it. Okay, and I can't tell which are in portals or out portals, but let's try running over some of them. You can see that sometimes the penguin is still on the screen after going through a portal, but other times I have to move the arrow keys to find the penguin. So I can work with what's here to get the program to essentially jump to where the penguin has landed, but it would be kludgy. I would want to redesign this to add that functionality. That's okay. This program I'm working from is just an example of loading a tiled background from a text file. It's not a game. A game would have a lot more mechanics built in that you could work with in designing your terrain, such as being able to zoom in and out, for example. This is just an example of how an inheritance structure for your terrain can allow you to add cool new terrain with minimal effort once you've set up the inheritance structure and process for building the terrain. I hope you enjoyed this, and I would love to know what you think. As always, the code examples will be in my GitHub repository with a link in the description. And as always, have fun and keep coding.